Today let's see the magnetization and the demagnetization. So we'll start with the concept of these two. We'll start seeing the concept of magnetization and the demagnetization. What do you mean when we say magnetization? Magnetization, this is the process of making a magnet from any magnetic substance, while this demagnetization is just the process by which a magnet is made to lose its magnetism. So demagnetization is just the opposite of magnetization. Now let's see the various methods which you can use to magnetize a substance or a component. Now there are various ways including as follows. The first one is the induction method, the second one is stroking method, and the third one is the electrical method. So let's start seeing the induction method. Uh, this induction method, this is done by placing a piece of unmagnetized steel bar or just any iron material near or in contact with the pole of a magnet and then removing it. As you can see here, where there's a steel substance here, like a little bar. In this case, just an iron nail, whereby we've placed here a magnet. So placing a magnet near this kind of a substance, a steel kind of substance or an iron material in contact or near with the magnet is just a way which you can create this steel bar or an iron nail to access or to have magnetism. So in this case, an iron nail pressed near a bar magnet will be induced with the magnetism. Moving on, the second one is the stroking method. This method is done by stroking a magnet into an magnetized steel bar. Now, there are two main ways or methods of stroking. Namely, the first one is the single touch, whereby in this a magnetized bar magnet is formed by a single stroke. So a single stroke is made to magnetize a substance. A single bar, take an example, a steel bar is struck repeatedly by a very strong bar magnetism, the same direction with the North Pole. This means, take an example from A to B, and the bar magnet is lifted at B, then returned at A. Then after several strokes, the steel bar will be magnetized with the North Pole at A and the South Pole at B. The second method of stroking method is the double touch, whereby two bar magnets are used to magnetize a single steel bar. The steel bar is magnetized by two bar magnets from its center to its ends using left and right ends simultaneously for several times. Between these, each stroke, the two bar magnets are lifted up high and returned to the center for another striking or stroking. As you can see there are two pieces of magnets. So they are the ones that I used for magnetizing this kind of a steel bar. So in this case, the steel bar will be magnetized with the south pole at A, where A is here, and the north pole at B here. Moving on. We have to note the following. Between successive strokes, the pole is lifted high above bar. Otherwise, the magnetism already induced it will tend to be weakened. So the magnet has to be removed. So otherwise, the magnetism that has already been induced within a steel bar or just an iron substance will tend to be weakened. Second one that you have to note that consequently poles will be formed at the center of the steel bar when the two bar magnets placed at the center of like poles. The same poles will be obtained on the same or both ends. So those are just two of the things that you have to note while using this stroking method. Let's see the third method of inducing magnetism. or known as magnetizing method, that is electrical method. In this way, a cylindrical coil wound with the main of insulated copper wire is connected in series with the battery. As you can see here, there is this cylindrical coil that is rounded with this main insulated copper wire. As you can see, the copper wire has been rounded. Now a steel bar is placed within the solenoid. The solenoid is this one, and the current is switched on and off. So the process of switching current on and off, as the current will flow through this rounded cylindrical coil, will make the material that is a steel bar here magnetized. So when the steel bar is removed and tested after some time of those repeated reaction of switching on and off, it is nearly or is just found to be magnetized. Now you have to note that if the current is switched off for so long, the bar will not be magnetized. So the switching on and off has to be simultaneous and within a break of a little time. Now, the pose of the bar magnet depends on the direction of the flow of the current. So the pose that will be formed of the bar magnet will much depend on the direction of flow of current, which you are trying to induce within a material. Now, the end at which the direction of the current is in clockwise direction will be the south pole, and if anti-clockwise, it will be the north pole. So you have to note that when you are trying to induce magnetism within a substance. Now let's see the various methods of demagnetization. Here I was simply seeing the ways in which you can remove the magnetism to a substance. Now the first, I just see methods of demagnetization. They include as follows: electrical method, that is the first one. We'll discuss it briefly. Then there is hitting a magnet. So if you hit a magnet, simply maybe for a time, it will lose it will lose its magnetism. And the third one is hammering while pointing east to west direction. So when you're hammering a magnet while pointing east to west direction, simply uh, the Earth's magnetism will simply cancel out the magnetism within a substance, making it demagnetized. This means that the magnetism will be removed to the substance. So let's further discuss about the electrical method, while those other two, I hope they are clear. Now, this electrical method, simply the magnet is placed inside a solenoid through which an alternating current is flowing. Now the magnet is withdrawn from the solenoid while the current is flowing, pointing to that west-east direction. Now, why is that? When the magnet is heading in a west-east direction, it does not remain with the residue magnetism due to the induction from the Earth's magnetic field. So that's the reason why the current is flowing, pointing in the west-east direction. Now let's see our last subtopic which we are going to discuss today, that is storing magnets. So magnets have to be stored so as to keep their magnetism and to avoid the demagnetization, that is the removing of magnetism to a substance. Now magnets are stored simply in a magnetic keepers. They are stored in pairs with the unlike poles together and with pieces of iron that are magnetic keepers across both ends. The keepers are magnetized simply by the induction method. So as you can see here, this is our magnetic keeper, and you can see here that there are a couple of bar magnets that are just stored there. So basically, guys, thank you for listening. I will discuss the magnetization and the demagnetization. We've seen the concept of magnetization, that is inducing the magnetism While demagnetization is just the opposite of magnetization, that is removing the magnetic components or just the magnetism to a substance. Then we've seen in the various methods of both of these two, the methods to induce the magnetism to a substance, and also the methods to remove the magnetism, that is demagnetization to a substance. Thank you.